Hello and welcome to the next video. We continue where we stopped somewhere here, and now we want to build a more complex model that may look a bit different. So I'm going to delete all these items that we don't need at the moment. And now let's assume that the model is the following. We assume that behavioral inhibition has impact on behavioral activation RR. This has impact on behavioral activation D, and at the end they all have impact on behavioral activation F. This is exactly why we need a structured equation model. We have the very complex relationship of the, abusive supervision regarding your supervisor has impact on the clients, and clients have impact on the feedback regarding your services. So kind of long model where you have different mediation or moderation. Moderation is, by the way, a bit harder to calculate it here. I will not do it in this video. If you want me to do it, let me know in the comments section. Otherwise, watch by video by James Gaskin. He explained how you do it. So now we try to do the model that I explained right now. So we assume that behavioral inhibition is our main independent variable. It has impact on behavioral activation R. Let's make it like up, like this. This model in turn, or this variable, has impact on behavioral activation D. I know it makes not so much sense from the point of view of theory, but we just want to play with the model. And at the end, it has impact on behavioral activation FF scale. And this is the relationship that we are going to have. These are the models. This is double mediation model that you can calculate with AMOS SPSS. Can be even more complex, can be something related to something else, so it can be a very complex model. And that is why we need AMOS, and that is why your sample size should be very big, because the more complex the model, the higher sample size. The rule of thumb is if you have one relationship, should be at least 60 participants. If you have two relationships, plus 30, so 90. If you have any additional error, plus 15 participants at least. This is the rule of thumb. And now let's make the model nice with the magic wand. Now we need error terms. Look at this. We have three dependent variables because these variables are dependent. This is the independent variable, so dependent variables should have error terms. And let's name the error terms. Now we save this model. I forgot, I think, to save the previous one, but okay, let's save at least this one, 004, and we call it SEM. I call it dummy, that you understand that it is not a real SEM because the model has no sense from the point of view of theory. And after we made it, we need to include some more tests. First of all, what we need, we want to have indirect effects because we have the mediated model, so we'll have indirect effects. Effects on BISFF via BSD and BSRR. And for this we need bootstrap. And bootstrap, usually you would take about 5,000 samples. In order to save our time, I take 2,000, but start with 5,000 or more. I have seen models with 18, 15,000, 20,000 samples. Bootstrapping is actually randomly selecting items from the data set and running the model again and again, and if you make it randomly, you increase the kind of statistical power, while the result should remain objectively more or less the same. And let's run this model. An error occurred. Bootstrap sample attempt was made to consume correlation between two variables. One of those estimate variance failed to be positive. Okay. So a mistake. Let's check standardized estimates. Let's see, maybe I have checked something that I shouldn't have. Output, standardized estimates. Let's get rid of this box and run it again. There are no some bootstrap sample template. Okay, just a second, try to find out what was the problem and continue in a second. So I found a mistake, at least in my event, was the arrow from BSRR to BSD. It had a problem with these two variables. I don't know what exactly was the reason, but after deletion it started working. Let's go to the results and let's see what we have. First of all, model fit, all good. Estimates, and now we can look at several things. First of all, we can look at direct effects. BIS has a weakly significant relationship to BAS, but I think, yeah, the more of inhibition, the less of activation you have. BIS has positive relationship RR and FF. They may be related, so probably there are some reasons why it is the case, but anyway. So remember, it is a dummy model, but we have found something that's significant. And we want now to go to the matrices. And here we want to look at the indirect effects. And if we look at the indirect effects, you can see whether we had some indirect effects. So BIS on BISFF. No, it is effect on BSD on the final. So we can see what effects we have. We have indirect effect from BIS to BISFF. We have the not only direct, it means we also have indirect effects. BISFF, these are the separate items. No, we need only these three items. We have one indirect effect. It means BIS and BISFF are indirectly related. Let's see what it is. It means we have not only the direct relationship, but we have also indirect relationship via one of these paths. If we go to bootstrap standard errors, we find what is the significance level, and it seems it is statistically significant on the p level of 0.025. It is significant. Again, remember, it makes not so much sense just because there is no theory behind it. We just wanted to play with the data. And this is how you actually test this complex relationship. You know the direct effects and indirect effects. You can delete one of the items. For instance, you can delete first BSRR and run the model, then you can introduce it back, delete BSD and run the model and see what is going to happen with the model to find out which of the effects is actually playing the main role. And what I also want to say, I wanted to find out the squared multiple correlations. And these are actually our R squared. And you can see the R squared, it means how much variance we explained in our BISRR is 0.28. So it is 2.8% is what we explain of variance using this BIS scale. What else you can do in this model? You can add control variables, you can add emotions again, you can try to play with this model, see how complex it can become, as complex as you want, but think about your data limitations, so it cannot be more complex than your data allows it to be. If you have only a few cases, you can run a very complex model. It works both for SPSS and for AMOS. It will calculate something, but nobody will trust the results. So I think with this in mind, we know already how to make confirmatory factor analysis, how to improve your model, and how to run regression analysis, and how to build a complex model using structure equation modeling tool AMOS within IBM SPSS package. I hope it was useful. I hope it was interesting. If you want to know more about how to report results, just look in some of my papers, of other papers of those who report structure equation models. See how they nicely depict the models. Let's see if I can find my paper with Shuradze and Wagner. We once wrote a paper. This is the paper in International Journal of Innovation Management, and I want to show you how we depicted this model and how we reported the results. In the confirmatory, this is the research model that we had, and then we had the confirmatory factor analysis, where we reported all the data, as you see here, the table that we had in Excel just recently with the alpha, composite reliability, AVE, MSV, and so on. Then we had the results section where I explained what we found, goodness of fit models, what indicators we used, and what they are. And then again we ran second confirmatory factor analysis because we had the several levels. It was the third level, third order construct. And then I want to show this is how we reported the model, and I think it is a kind of nice way to depict your model. This is how it should be. Here are the weights, here are the weights, here are the loadings, here is the weights, but we use a bit different tool to have the third order construct, and then we have the R squared reported here, where you can see this is the R squared. These are the paths that we had. We had the mediation model. It means we calculated the all model with the mediator and without the mediator. This is C and C# path, and this is how we reported the data. And instead of writing here the names of the items, we just wrote item 1, item 2, and at the end of the paper we introduced the items, how they were measured. Let's see, we can find the table just to see how we did. Yeah, you can find what is the construct, what was the item, how it was measured, and what we actually asked. I hope it helps you reporting your structure equation model. Good luck with your research, and let me know in the comment section if you need any information or any help. See you and good luck.